right, hi everyone. I hope you're doing well during this time. Hope you had a nice weekend. We're ready to start week 3, which in my opinion is a lot easier than week 2 with the quadratic formula. So I appreciate those of you that worked hard last week and attempted the quadratic formula. I know it was pretty hard, especially with no support from me in class. So I promise this unit is a lot easier in my opinion. It's 8.9. The objective is I can differentiate between linear, exponential, and quadratic functions. So just like always, I have a blank copy of the notes on Google Classroom. So if you have access to a printer, you can print them out. If you're someone that learns best by writing things out on your own, you can rewrite it on your own. Otherwise, there's no need for you to even do that because I do have the filled out copy also on Google Classroom right here. So you're welcome to just use this. The notes are not graded, so what I grade is the practice, okay? So the notes are just to help you. Some people, like I said, like to write out their own notes. I know that's how I learned best myself, was to write things out, even a couple times. But you're welcome to just use my notes, so these are just here as a supplement for you guys. You don't need to actually write them out. So I'll go ahead and go over these with you, and then I'll go over the practice. So again, our objective is I can differentiate, which means I can tell the difference between linear, exponential, and quadratic functions. So hopefully you have heard the words linear, exponential, and quadratic in Algebra 1-2. Okay, so just to review what all of these mean. Linear means it makes a straight line. So remember that the first 4 letters of linear spell out the word line. Okay, so a linear function will make a straight line if you graph it. It will have x all by itself, which I'll show you some examples of that. So in an equation, it won't have like x squared or an exponent of x. It'll just have a regular x. And we get linear functions by adding or subtracting the same number each time. So we're not using multiplication, we're adding or subtracting. So think about if you work and you get paid $10 an hour, the number of hours you work, each hour you get to add $10 and that's how much you make. So that would be a linear function. Another really easy example is each year we get 1 year older. So each year you add on 1 year to your age, that makes a linear function. So if we're looking at equations, we could have y equals mx plus b. So that form of equation, which hopefully you recognize from the past, we could also have ax plus by equals c form. So there's a couple different ways we could have this, but the key is that it makes a straight line and that it has x by itself. Okay? Exponential makes a curve like a Nike swoosh. So I'll show you like this middle one right here. Okay, so it has a very sharp curve, and I call it like a Nike swoosh. It will have the exponent of x. So think of like 3 to the x power right here. Let's see, so I can highlight this. Okay, so it has the little x there. Think of exponent, exponential, okay? And it comes by multiplying the same number each time. So we're not adding or subtracting, we're multiplying. So this one is good for percentages. If you get like a 2% raise, that will increase your salary exponentially. It will make it a lot bigger. Right now, for example, with the coronavirus, there are many cases added or each day. So the number kind of multiplies. So the number of cases with the coronavirus right now grows exponentially because it grows super fast. I have an app that I look at. When I first started looking at it back in, mid-March, there were only 75 cases and now we're up to like 3,000. So exponential will get there a lot faster than linear. Linear would just be, let's say that we added 10 cases of the coronavirus each day. Exponential means we multiply, so it's going to be a bigger number in the end. And lastly, quadratic is what we've been working on for a while with Algebra 2. So it makes that parabola or U-shaped curve. It will have x squared, so it'll have x squared in the equation, or it'll have some form that will end up as x squared, okay? So for example, this is factored form here. It doesn't say x squared right away, but if we did the box method and we multiplied that, we would get x times x here, x times x, which would give us x squared. So it would give us, eventually it would give us x squared. Or this here, this is vertex form, which we just learned 2 units ago. This one here, a little hard to do with one hand, there we go. If we had to take this outside of the parentheses, it would be it would be x squared, because we're taking the exponent and we're putting it to what's in the parentheses. So that would also end up x squared, okay? So graphs, in my opinion, are pretty easy to tell the difference of if it's linear, exponential, quadratic, or even neither. So this here is quadratic because it makes a parabola. This middle one is exponential because it kind of looks like a Nike swoosh. It's a very sharp curve. And linear, of course, makes a straight line. Here's some equations. So if we have this one here, y equals 3x plus 2, well, we have x by itself, okay? There's no x with an exponent. X as an exponent. There's no x squared. So because it tells us up here that if it's just going to have x by itself, it's going to be linear. So we know that first one is linear. Same thing with this middle one. We have 2x plus 3y equals 6. So the x here is just a regular x. It's not an exponent and it's not x squared. So it's going to be linear.